Hello, everyone. Thank you for joining us today as we come together to learn more about architecting for scale. My name is Hussam Mohsine. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Christopher Maneu. Christopher is a senior cloud engineer and startups developer advocate at Microsoft. His mission is to help every technologist on the planet succeed, focusing on startups. He works with and helps and teaches developers across the continent on cloud and open source technologies. Feel free to ask questions during the session. We will have regular stops to answer these questions, and also feel free to tweet about the session and tag us on Reactor Abu Dhabi. That's the Twitter hashtag, and MSFT Reactor is the Twitter handle. And make sure you also adjust the playback setting to select the highest quality for the best experience. With all that said, I hand over the mic to our speaker to start the session.
Thank you, Sam. Hello, everybody, and welcome to this session about architecting for scale. So let me share my slides and we can get started. As Sam said, if you have any question, feel free to drop it in the Q&A section. It should be at the right of your screen. I will make regular pauses to go through the questions and try to answer them directly during the presentation. We will also have a bit of time after the presentation to answer any other question you may have. So architecting for scale, maybe you're not really comfortable with this title because one of the issues with this session title is actually what does scales mean? And when you're working in a startup environment, and I've been working in different startup and scale-ups from the bootstrap startup to the unicorn, and scale means things differently depending on the person or depending on the stage of startup. So scale can mean a lot of different things. It can simply means you're growing your company, and so you're growing the number of headcounts of your employees. It probably means that you're growing the product usage or the number of users as well. It can mean you're scaling the number of features, the reach of your product. Maybe you've started with a narrowed MVP, minimum viable product, for beginning your startups, and then you're growing, adding more features, etc. And it's can be difficult to manage a product with a huge number of new feature every month, for example. When you're scaling your startup, when you're going from 5 to 10 employees, from 10 to 20 employees, from 20 to 100 employees, you will also need to scale your operations because you're managing more employees, more customers, etc. So you need to scale your customer support service. You need to scale other aspects of your company so you can continue to grow. And obviously, probably at some point when you found product market fit, you will need to scale your sales and growth engines so you can have more customers, know that you have a great product for a specific audience. So architecting for scale, actually, we can talk about all these different things. But for today's talk, I will focus more on the product usage, product users, and specifically what it does means for the technical team, the engineering teams within your organization. So I will not go over the other aspects. Some of them I have absolutely no experience at all. For example, on sales and growth engines. For other one like employee headcount, feature operations, I definitely have things to share. So if it's one of the topics you want to learn more about, feel free to say it in the Q&A section, or maybe there is an item in the Reactor survey I encourage you to fill out at the end of the presentation, so we can maybe program a future presentation around the other scaling issue you may encounter within the startup. The other aspect of our architecting for scale is the fact that not every startup will scale in the same way. What kind of growth you can expect? Maybe for some of you, if you grow 10x, it's already a huge milestone and you could be proud of you. But maybe for other ones, you want to scale much more than that. And also, depending on your startup stage, you're not facing or you're not preparing for the same growth. Over what period of time? And this is very tricky and also very important question. If you need to scale over a period of 2 years, you have time to do things. But if you need to scale in a period of 2 days because you sign up a huge contract, or you will be showcased on a national TV, so you know you will hit a huge number of users very, very quickly, and you need to prepare for that. Definitely your options are more limited. So we will try to cover things that allows you to scale very quickly, but also things you can do over time to better scale at a more slight pace than 2 days. So my job right now is to give you some ideas and some techniques you can start using just after this presentation for architecting for scale. And I will go over them in roughly about 40 minutes, so we have plenty of time for Q&A. And as I said, feel free to start asking your question right now so we can answer them during the presentation. So what I will cover today is first a set of main principles I try to apply when I'm tasked to actually architect for scale. And then I will go over some recipes I've used in the past, but allows me to scale a bit of my application, a bit of my product very easily, very quickly, without having to re-architect everything. Because sometimes, as I said, you need to scale a few things very, very quickly, and you don't have time to rewrite everything. So for the main principles, I have a few of them. I will show you all these principles, and then I will go over into details into one of them, each of them. Sorry. So the first one is know your enemies. The second one is understand your scale access. The third one is relax time boundaries, and the last one is limit your state. So we will go over each one of them, and I will start by know your enemies. One of the enemies in most of startup I worked in, and in most of startup I've coached during the years, is over engineering. Because most of the developers working in a startup environment are very passionate about their work. They want to do the perfect thing, and they want to be sure that, yes, if we have huge success, the system will actually work while having the success. So they tend most of the time to over-engineer things, and this could be quite bad in a startup environment because we are all limited in all organizations. Even at Microsoft, we have a limit, budget limit. Maybe it's money, maybe it's time or number of developers, but we are all limited. And when you're in startup, what you're trying to do is to craft the perfect product that actually answer to real issue to your customers. And over engineering, spending time over engineering things is time you will not have to actually craft the best feature. So one of the key I'm trying to apply to all the startup architecture projects is the following one. I will try to put a design in place that will support something around 20x growth from current system load. So maybe today you only have 100 users per day, but you want to support thousands of users a day. You know that you will achieve this growth maybe within a year if everything goes well. So you will design now for this projected growth. But the key is just to only design for this growth and only implement for much more limited growth. So you will not spend too much engineering time upfront to actually design a very robust and very scalable system, but you will make the hard choices right now and implement something much lighter. So while you are entering this growth over the months, you can actually re-implement only part of your application, part of your services to support the new growth, but you already had the foundation to support this growth. So by doing so, it could be a tricky exercise, but when you're doing architecture discussion within an organization, try to have this in mind, because one of the time it gives you a north star from where you want to go, but actually you have a path to go to that specific target over time and not doing everything upfront. And if you have to deploy things like deploy servers, I do not actually deploy all my servers obviously upfront. We only deploy roughly 1.5x my numbers of server needed for my current growth. So if I have some spike in traffic, I can probably handle it. But if I have a sustained growth, then I will need to deploy more servers. But the fact is, I will not have to pay for these servers until I have that specific growth. So my next point within the NMS is understanding all the limits. And when I had discussion with, I have from time to time discussion with CTOs of startup who actually failed at some scaling. Most of the time, as I said in my introduction, is when a startup gets a chance to be featured on a national TV or national magazine, that kind of things, they enter a huge number of users in a very specific time frame, and then they fail to serve the customer, to serve the request. The website is down for a few hours, and most of the time is part because of the architecture, but it's not scalable simply, but also because they didn't understood all the limits of their systems. And the fact is, you can categorize all these limits into two different categories. The first one is your own limits, because you have a specific team capacity. If you have only 3 developers, they will be able to code a certain amount of things. But if you're, because you need to re-architecture things, you need to have much more horsepower in the development side, and you don't have it, you will hit the wall for sure. The other one is the software design, how your actual design is limiting yourself for future growth. And all the game is to actually understand these limits and know when to react, so you're not too far away from the next growth stage, but you're also not too close to the wall, and so you don't hit the wall. And the other thing people tend to not understand, and even if you're using a cloud solution like Azure, is that all the services, all the open source project libraries and framework you're using have most of the time some limits baked in. It could be hard limits, hard platform limits, or it could be software limits or scalability targets that sometimes you can go over capacity, but kind of in a limited way. So if you're using Azure, for example, one of the best resources you will have around it is what's called the scalability targets. So the scalability targets is a simple document that actually explain you details all the limits of the Azure services. For example, you cannot hit more than X number of requests on an Azure storage account. So if you have a huge number of users and all of them need to access 2 files within the storage account, then you need to be aware of this. And if you're going up this limit, maybe you need to split all your users onto 2 different storage accounts. And the same thing exists for also some software. Maybe you're using a specific protocol that limits the number of incoming connections. So if you go over this number of incoming connections, you will have some issue as well. I wanted to give you a real-world example of us, not in the startup space, but still interesting how the team decided pick a technology and actually being able to get over more and more traffic over time without having to re-architect everything. And this real-world sample come from the Office licensing team. So this team is responsible for building and operating a service that do licensing activation for all the Office client apps in the world. So it's not only the Windows and Mac Office clients, it's also all the mobile applications in the world. It's hits roughly about 240 million times a day. So it's quite a huge service in terms of traffic. And actually, the backend service they used changed over time to accommodate growth of usage. They started by using Azure table storage for this onto one storage account and using multiple tables for multiple needs. So this is a great idea because the Azure table storage is actually very cheap, and actually you can have a huge growth just with it. It's not for all your data needs. I'm not saying you should ditch your SQL database for table storage, but for some usages, it's much more efficient to use the Azure table storage. And then they reach the scalability target of one single storage account. As I said, one storage account have a certain amount of requests it can handle per minute. So what they've done for the next stage is basically they didn't change so much of the code. They were still using the table storage, but each table, instead of having all the tables within the same storage account, they split each table into its own storage account. So if, like in this example, you have 3 tables storing all your data, basically by doing so, you're multiplying by 3 the amount of requests you can support. And then the next stage, and it's today's stage is that one, is they moved all the tables to Cosmos DB. Cosmos DB is a multimodal database in Azure. And the fact is Cosmos DB has an API for table storage. So again, from a developer perspective, the only thing they have to change is kind of the connection thing and the way you connect to the database, but all the code related to adding data or querying data, etc., has been unchanged between the 3 different stages. So this is actually perfect example of the main rule I said within Know Your Enemies, which is architect for 10x growth, but implement for 3x growth and deploy for less than that. And that's exactly what they've done here. Because they put the partition key at the beginning, they've been able to and partition the data. They've been able to grow in different stages, and for each stage, they only need a very limited amount of engineering efforts to actually move to the next stage. So next principle is understand your scale access. The fact is there is different ways to scale. You can scale horizontally. It's the most efficient way to scale, but it's not the most practical way to scale. What it does mean scaling horizontally is basically means adding more servers that have the same purpose or the same code base on it. The issue here is to be able to scale horizontally, you need to have a state managed somehow, and most of the time it's complicated to have a state and scale horizontally at the same time. But it's the best way to scale to infinite scale. But again, maybe, maybe for your application, your current architecture, going to scale horizontally would require a lot of re-engineering of your actual code. So there is other way to scale. You can scale by function or service. Let's say you're building a social media website for very targeted audience, and you have a feature that actually allows you to upload very high quality images and videos, but you only share like a medium low quality images, and people can, if they want, they can download the high quality media. So what you have to do somewhere in your code is to resize all the images that got uploaded. This requires a lot of CPU and memory. So maybe one of the things is to identify within your application, within your product, which features of your product are actually consuming a lot of CPU, memory, or resources, and export them to a different service. So that way you can scale the service independently and scale much more easily the main application. And with Azure, we have a ton of services that allows you to do this, from messages bus to Azure functions. You can do this most of the time pretty easily. And the next way to scale is to scaling by partitioning or by tenants. Depending on your application, if you're, for example, if you're doing a B2B, if you're in the B2B market, maybe you have one or two of your customers that are so big that they represent at least 50% or maybe more of all your total usage. So maybe one of the things you want to do is to actually isolate these high customers into very specific deployments and all the small ones into a shared environment. So it's most of the time it's something that is quite easy to do. The only thing you have to do is to kind of have somewhere most of the time in the user management system information about the tenant of a specific user, and then you redirect them to a different URI like server1.yourapplication.com or server2.yourapplication.com. So it could be quite easy to do, and then you can have you cannot scale indefinitely like this, but definitely you can give you much more headroom quite easy. And actually, we had a question from Nish. What are the factors to consider when scaling a single tenant SaaS application to multi-tenants? And I partly answer the question just right now. One of the factors you want to consider is one of your tenants like a busy neighbor for your other tenants? So if one of your tenants is very active on your application and consuming a lot of resources, then it's maybe something you want to consider to isolate them from the other tenants. One of the other aspects, it's more business one, but sometimes you can have a premium offering where you guarantee better SLAs or better performance, and then you can also tier all your tenants depending on this specific pricing. So all the premium customers tenants get deployed onto high-end deployments with huge machines and then capacity, etc., and smaller smaller users with smaller plans got deployed onto a much more normal environment and not a high power environment. One of the things we do in some of the products is, for example, you can check this out on Azure DevOps. So Azure DevOps is basically a suite of tools for collaborating across the product management and the development, sharing your code, doing pull requests, doing builds and deployments, etc. And what we've done within Azure DevOps is we created a unit of resources consumed per request and per user. And it takes into account the SQL database that's being used and all the CPU that's being used by a specific customer. And you have a way to, as a customer, you have a way to see how many units, consumption units you have used. So maybe depending on your application, for example, if you're creating a service that will process something, like crunch some numbers or process a video file or process 3D graphics, that kind of things, you can probably create that kind of virtual currency for resource usage, and that may be something you want to consider when scaling an app to a multi-tenant app. Then go on to the next principle, which is relaxed time boundaries. Not everything is priority zero. And I had that discussion, I don't know, so many times with CTO and lead engineers at startup and even at big corporations, where people keep telling me, yeah, we need to have a 100% SLA, or we need this to be instant. When the user clicks on this button, everything needs to be done. However, they didn't have, most of the time, they didn't have the resources to actually keep these promises. And the fact is, when we think about it, a lot of things within our application and services can be delayed by, I don't know, between 1 and 10 seconds, and the world will not stop working. So we need to think about it within a product and try to see if we can have, instead of a synchronous operation, so when you click on a button, then something happens in the background and everything gets processed at the minute, maybe you can have some asynchronous work and push all this all this work in a background service that will process the things. The other need to think about is consistency levels. Obviously, when you're doing, I don't know, banking, and if you're doing a wire transfer of money between account A and account B, you want to be at the same second. If you remove some money from the account B and add some money from account A, sorry, and add some money to account B, you want this to happen at the same time and not having some disparity between the two accounts. But I don't know, if you're sending an email campaign, maybe delaying the email from 10 seconds or a minute is not a big deal. So you need to think about it and see if you can relax a bit your consistency level, because if you can do, you will have much more technical choices to actually implement the feature. And it's basic advice, but again, I see a lot of startups not using this early on, is using a message bus and background workers. So as I said, for my social media website, when you can resize images, do not resize the image on the fly. Get a process. When you upload this image, just push a message to a message bus and then have background worker get this message and actually process the image. If you want to do this exact scenario, we have better ways to do it in Azure. But for generic scenarios, pushing a message onto a bus and having a background worker can help you, because you can relax, remove some some pressure onto your front-end servers, and having these backend services handle the rest. And if you have a spike in usage, this spike will be actually taken by the message bus itself and not by your own servers. So if you're relaxing time boundaries, you can also do other interesting things on the data side. For example, you can use the pattern read on replicas. You may already know it, but it's very difficult to actually scale a SQL database in terms of quantity of data, but also in terms of querying performance. But one of the things you can actually do to scale, and especially if you have a large number of user reading data from the database, like an e-commerce website, most of the users are actually reading data and not writing data. What you can do is to use a read replica. So basically, you have master database. We can rename the master database by, I don't know, principal database, but it's a read-write database, and it's the source of truth. Okay, and then you can have a read replica, and just have within your code a simple logic, which is if you are doing a select query, then use the read replica database. And if you are actually writing something, then write onto the main database. By doing so, you can have multiple read replicas. And so if your read-write ratio is disproportionate in favor of reads, then you will be able to scale quite easily the number of users without having to re-architecture a lot of your application. But to allow this, you need to relax the time boundaries, because the whatever kind of SQL database you're using, SQL Server, MySQL, MariaDB, PostgreSQL, etc., when you implement replication, you will have a lag between somebody writing something onto the main database and somebody actually being able to read that new data on a replica. So you need to relax the time boundaries to allow you to use this architecture. The other thing you can do if you relax time boundaries is to actually do what we call a background write. So that in that case, we want to scale the number of writes you can do onto database. And what we do for doing this is we actually do not have code to write directly from your web application to the MySQL database, but we actually have the front-end application send a message to a message bus, and then having a background worker actually do the writings. By doing so, you may have some lags if you have a lot of queries over a short period of time, but you will not overflow your databases with a lot of requests. Our last principle is limit your state. So almost all applications needs to have some state somehow and need to manage some state. However, there is a lot of things. We need to broaden what we see by state. What do we mean by state, and how the state should be stored. Our objective is to strive for stateless services. The more stateless services you have, the more scale you will be able to have. Obviously, at some point in time, you will need to have some state, but you can do a lot of things to actually remove the state from a lot of parts of your applications. One of the things you can do is to actually try to push the state onto the client itself. Most of our applications have a front end, a web front end, or a mobile application front end, or a desktop front end. And these devices can actually do a lot of different things. For example, with HTML5, we have access to local storage where we can store a lot of different things onto it. So try to push some state onto the client itself. For example, if you are doing, if you have a complex authorization mechanism within your application with a lot of rights to manage, etc. If you're using GWT tokens, you can embed claims within this token, and doing so, you don't have within your code, you don't have to request a central store or central database, user database, to actually see if this specific user has a right to do a specific actions. So that's a way to push states onto the client and to free you to do other things and to scale better. You can use a specialized service. You can use Redis, for example, or any key value store to do this. And sometimes you can explore specific patterns, for example, the actor model or the durable functions we have on Azure. Actor model is a generic thing. You can do it on a lot of different languages and platforms. Because these patterns may help you actually forget about managing the states and push all these management issues onto the stack itself and not within your code. If you want to learn more about this, I encourage you to check out this link. Oh, and I didn't see it at the beginning of my presentation, but you will have access to all the slides just after the presentation. So that was all for the main principle. Before going into the recipes, I will check the question because I saw a few questions that pop up into my chat window. If you have more, please send them along the way. So we have a question from Matthew, I think. I hope I pronounced your name correctly. You're surprised I have not mentioned volume load testing to provide the evidence for where the application breaks, failure scenarios, where the application hits limits, etc. What volume load testing capabilities are there for Azure? And Matthew, you have a very, very great point. The only way to be sure that all your application is actually going to resist to a huge load is to actually test it. So definitely, if you're architecting for scale, you will need to load test your application. And when I say load test your application, I mean every component of your application, because when you're under huge load, every details counts. I worked in the past for as I said, for a scale up, we had dozens of millions users a day, and at countless time we had issue not because we have scale issues, not because we changed something in our architecture or in our infrastructure. So the server stays the same, the switch stays the same, the network stays the same, etc. But we pushed just 2 or 3 bad lines of code that end up being within a critical path during a user connection, for example, user authentication, and then we basically shut down the website. So you definitely need to understand all the limits, but also test all the limits. We don't have right now, we don't have any load testing offering from Microsoft for Azure, but we have several partners that actually give you tools to create load testing for Azure workloads. One of them is Gatling. I will try to actually give you a link within the search window. Gatling tests. Yeah, that was one. I will add as a reply to your question, Matthew. It's open source load testing library, and they have an enterprise version that you can find directly into the Azure Marketplace. I will add this link as well. So basically, you can write your own tests and use it locally, and then when you're just before the release of a major new version of your product, then you can use the hosted version to actually generate a sufficient load. One of the things you need to be aware of if you want to do this is things will break and things will cost money. So you need to be very careful about your load testing and maybe going incremental, depending on what your target is, but start by generating 100 user sessions and then go to 1,000 user session and then go to 5,000 user session. And I'm not going 5,000 from the beginning. The other thing you may be interested in is, and I mentioned it at the end of my presentation, is actually there is, so you need to understand the limits, you need to test the limits, that's the second step, and then you need to protect or to avoid these actual limits. And one of the patterns we have for this, let me fighting, is called throttling. Sorry for my very bad English accent on this word, specific word. And again, I will add you a link as an answer to a question. But it's basically a pattern that allows you to, from a software perspective, limit the number of incoming requests into your system before you actually break the system. So for doing this, you actually need to test it. And when you've tested and you know that your current deployment can handle 100 requests per second max, then you can put a throttling policy at, I don't know, 80 requests per second. So you will have room. So nobody, some people will not have access to their requests and not have the answers, but actually you don't break the system. So very good question, Matthew, and definitely a topic we can spend a bit more time on it. Another question, I didn't get your name. So actually 2 comments. First, the background write technique is also known as queue-based load leveling. You're totally correct, and your link is a relevant one around this pattern. There is no good tool for modeling simulating execution for scalability limits. The limit specification we have same as protocols, various MSD and docs, pricing calculator, and other tools. Yes, you're correct. It's complicated to get a 100 feet, 10,000 feet view of all your scalability limits when you're deploying something onto any kind of hosting provider or platform, actually. I don't have any good answer for that, to be honest. Yes, it's a complicated topic, and depending on your application and the complexity of the application and the numbers of components involved, it could be a tedious work. On the occasion, I had to actually craft a plan for this, and a very detailed plan. My tool of preference was Excel, and I've done a bunch of things, crazy things into Excel to actually being able to do it. So feel free to send any other questions. I will go over to the next section, which is the recipes, but we will have a few minutes again at the end to answer a few more questions. So let's get ahead and talk about these recipes. So this first one is an easy one. But again, a lot of people are not doing it, so maybe we need to state it over and over and over, is move your static content to CDN. When I say static content, I said all the files that are not your code and that don't move or don't change so often. So the usual suspects are CSS and JavaScript files, and also all the images or documents you can have on your website that don't change so much. Most of the time, it could be quite easy to move your content to CDN if you're using some of the Azure products like Azure Front Door. It's even easier to do it on specific path of your websites. But that's definitely something most of the people need to think about, because any content that is requested from the CDN is content that is not requested from your own servers, and it's again more bandwidth for other important requests. Aligned with this recipe number 1 is recipe number 2, use cache headers accordingly. There is a huge, when you're doing a web application, there is a huge number of cache layers happening in your server, within your ISP, within your company, and within your actual device. And a lot of people are not setting these cache headers properly, and so they miss the opportunity to actually store a lot of things on the client. And again, if the client needs some file that is local, it's again a new request that didn't hit your server, and so you have more bandwidth. Number 3, I already say a word of this, but is take advantage of everything you can take on from the client side. So service worker and local storage, if you're doing web HTML based application, is definitely something you want to look into. Step number 4 is use cache aside patterns. So to give you a quick definition of this is, let's say you're doing an e-commerce website and you have a list of products on your homepage. All the details of these products are actually stored in a SQL database. If you're doing a naive implementation of this, each time a user will request your homepage, we'll actually have to query the database itself. It's not very efficient. One of the things you can do is, for example, every 5 minutes or every 1 hour, depending on your website, you actually go query the data from the database, but you cache it on another facility. It could be in-memory cache. It could be a specific service like Redis or Memcache for doing this. But all the requests, the subsequent requests that will hit the cache, will be actually requests that, again, do not hit the database and give you much more headroom. Number 5, scale through cloud services. It's easy for me to say as a Microsoft employee and an Azure engineer, but the fact is, there is things you can do on the cloud you cannot do on traditional hosting solutions. And even if most of your application, most of your product is actually deployed onto on-premises servers, sometimes you can offload part of your traffic or part of the features on the cloud. So you don't have, it's not an on and off solution. If you already have deployed something which is not on Azure, you can still benefit from Azure from specific tasks. So think about it. And again, we have plenty of people to help you on Reactor or on the cloud advocacy team. Number 6, evaluate serverless for scale-sensitive services. So serverless is a group of technologies that basically remove the thinking about a server. It's not, there is no server behind it, but the fact is you don't think about the servers. You only deploy a piece of code, and this piece of code will get hosted and will get executed without having you to think about it. And most of the time, you can have quite huge scale by using these serverless offerings. So go check out all these services because, again, in some scenarios, it's really helpful to get a great scale. And again, you don't have to rewrite all your application to be serverless to actually benefit from a serverless architecture. Number 7 is do not use only one data store. When I have discussion with startups and CDOs, I see a lot of startups having only one data store, mostly a SQL one. And again, MariaDB, PostgreSQL, SQL Server, etc. I'm not against all these stores. They are great for a lot of different things, but sometimes by storing only 1 or 2 tables out of this SQL data stores and store them in other type of data stores, NoSQL, document, key value, etc., you will be able to scale much more your application and even maybe gain some other benefits out of it. So again, you need to think about when you're creating a new table, you need to think about what the access pattern are. Is is the application, is the data from this table is still accessed the same way, or if sometimes like 70% of the requests, we only need 3 information out of 10 columns, and then we already know this and this field and this field. So maybe we need to duplicate the data maybe, or to store this table onto a much more specific storage to get better performance or better scalability. With that comes the partition your data recipe. Something you need to do depending on your data store. Again, if you're using a key value data store, sometimes you need to actually partition your data. But partitioning your data could be by tenant, could be by user, could be by a huge number of different properties that will allow you to scale much more easily. Because one of the things you can do is to actually say partition your data in 10 and partition 1 to 5 is going into this one database, and 6 to 10 will go to another instance of the same database. And if you're doing so, you will be able to scale again very easily, because at the maximum you can deploy one database instance per partition. And you can again start with only one deployment. If you go back to my first main principle, you can actually, even if you have a very low number of users or specific data, think about how you can partition, what is the partition key of this specific type of data, put everything into the same table, same data store. But by doing so early, you know that if you need to partition your data in the future, you will be able to do it. I already touched a word about this in recipe number 7, but think about data denormalization or duplication. As I said, maybe you can, one table is very important, but maybe part of your application only needs 2 or 3 items, 2 or 3 columns from this specific table. So maybe extract this and put a copy onto another data store that will be used for a specific purpose. You will need to manage the duplication of data, which is something to do, is not free in terms of development and maintenance, but maybe you will get something out of it, but basically remove the friction of doing it. Design for rollback. So I told you about my unicorn startup issue where we deploy 3 lines of code that basically have a mistake in it, and the website blew up. It's important when you're doing things, and it could be very tricky at the beginning of your product. But designing for rollback, when you do something, you need to be able to roll it back quite easily. So you need to think about it, because sometimes it's a slight modification of code or database index, etc., that will just put your website down. I already told you about throttling, but limit your blast radius is something quite important and something we don't think enough about. All the idea behind the blast radius is when you're doing any change in your application or infrastructure, you need to limit the impact of this specific change, the blast radius. And you can do this by doing several things. One of them is putting throttling in place, as I said, and the other one is using what we call feature flags. Feature flags are markers in your code that allows you to turn on and off a specific feature or a specific piece of code without having to redeploy anything onto your system. So there is a ton of ways to actually implement feature flags. We even have in Azure the Azure App Configuration Service that has a feature flag management feature in preview right now. But the idea is, for example, if you create a new download your invoice in PDF feature, maybe put this feature behind the feature flag and only enable it for a specific subset of your users. And then grow this specific number, this specific subset over time. So if you made any mistake within this code, scale-wise, you don't have to actually roll back to preserve your website and your product. And the last one could be complicated depending on your business, but I know a few high-profile websites that are doing it and actually used it in the past. Is a static read-only emergency version of your app. Let's say you're doing a housing rental listing website, so people can search for a new home and rent it. 95% of your website is only reading data, and 5% maybe I want to get the contact of the agent for this specific house of apartment. So you can maybe each night generate a static version of your website and have it already deployed on a spare instance or behind a CDN. And if something very bad happens within your application, you can just flip a switch and send all your data to this specific emergency version of your website. So you will still keep your users with a subpar experience, but they still get access to your website. Again, you cannot do it for every type of applications, but maybe for some applications of some part of the application, you can have an emergency plan. And this emergency plan could be a static read-only version of your app. So to summarize all these things is all these recipes and principles are here to help you to be prepared for the next wave. Definitely, you need to know your trade-off because you will not be able to do, as you have all limited capacity, you will not be able to implement all of these 12 recipes and all of these principles. So you need to know your trade-off and to make choices, but you will be able probably to do it better with all this knowledge. Have your monitoring ready, because when something bad happens, you will need to pinpoint the issue, and you will also need to have a monitoring solution that can actually handle another great load. And learn from your failures. We all failed. I failed several times in the past for some scaling issues, and I've learned along the way a lot of different things. I wanted to give you a few takeaways. The first one is a scalability checklist on our documentation with a lot of different points you can go through to ensure that your system should be scalable. I already talk, and someone from the audience also send a link to the cloud design patterns, which is a series of design patterns that are useful in a cloud context, but also if you're not using not actually using cloud technologies, you can still learn interesting things about scalability, reliability on these design patterns. Sorry, and the last takeaways is actually a book. A free book you can download, Designing Distributed System. It's been written by Brendan Burns, a colleague of mine, who is a co-creator of Kubernetes, and it goes through some of the underlying issues of creating and designing distributed systems. So I have a few other questions. So Hamad, thank you. And yes, I have other resources. I mentioned them. Is there a good guide for comparing various caching services in Azure, CDN, Redis, Founder, etc.? Oh, what is a CDN? Sorry, Jonathan, I didn't explain what is a CDN. It means a content delivery network, and it's basically a group of servers optimized for delivering content, static assets. Usam, you send a link to the Microsoft Reactor. I think we are out of time. I still have one or two questions to answer. Do I have time to answer them right now?
Sure, you can go ahead, please.
Okay, great. So if you need to leave for any reasons, I will just drop right now the links to the slides, and then I will answer to the remaining questions. So yeah, Jonathan, sorry, I didn't explain CDN. I've just did. And another question, is there a good guide for comparing and contrasting various caching services in Azure, like CDN versus Azure Redis versus Fondor, etc.? So we have some documentations. The fact is there is different kind of caches. Azure CDN and Azure Fondor have both CDN capabilities, so caching static content. Azure Redis is much more for developer to, when he knows he has something that will some kind of data that doesn't change so often, and you take time to get or to compute, then you can use Azure Redis as a cache side store. So we don't have a good guide for comparing all these services. But for example, if you want to compare Azure CDN and Azure Fondor, we have this kind of comparison within our documentation on docs.microsoft.com. I'm trying to skim all the questions and be sure I answer all of them. Another question, how do you roll back with a microservices model? It will depend on a lot of different things and how do you deploy your microservices. But basically, you have most of the time when you have a microservice model, you have two kinds of updates. You have small updates, which is kind of you're changing something within the microservice itself, but it didn't change the interface these microservices as with the rest of your application. So for example, if you're doing it with Kubernetes, for example, it should be easy. You just have to roll back to the last image of these microservices. If you're doing this for changing an interface somehow, or changing a bunch of different microservices at the same time, then you can hit more complex issues. Yes, you can have, it will depend on a lot of different things, but you can definitely do it. One other thing I want to add on top of this very quickly is if you're using a message bus, you will probably want to version the message schema. And it's really important because let's say you have a first version of a message between your web app and a background worker, and you want to update it to add a new feature. The fact is, when you will update the background service, you may actually have within your pipe still messages in version 1 still to be processed. And your code need to be able to process all the different versions of your messages. So there is two things to be aware when you want to version things in this area as well. A few people ask for the links to these books. As I said, you can have it on my slide, and I share the links to the slides. And I think, Issam, you have a last word to say. So when you're while you're doing this, I will put all the other links in the chat window.
Thank you, Christopher, for this great session. And I'm gonna share a couple of things with our community. Do you mind turning the speaker off a bit? I can hear my echo.
Sure.
All right, so very quickly, I just want to share with you the Reactor survey and a few upcoming webinars. So for the survey, this is an important one to share your feedback about today's session and about the topics that you would like us to discuss in the Reactor. It helps us accommodate these topics in the future sessions. So please take a minute or two to check out the survey. I pasted the link in the Q&A section, and I will add everything I'm going to share here as links as well to the Q&A section. There's an important thing there. There is an event code for today's session, which is 7786. So use it when you are providing the feedback on the survey. So that's pretty much about the survey. Few upcoming sessions. So on Sunday, July 5th, we have a session on Kubernetes best practices. We will cover how to simplify the development, management, and operation of Kubernetes. We will also discuss the tools and the best practices to help you with cluster and pod scaling, policies, security, container monitoring, and logging. So that's on Sunday. On Monday, July 6th, we will be talking about Python and Pandas library, how you can manipulate and analyze data, as well as learning how to split and join data frames. And on Wednesday, July 8th, we will be learning how to get started developing, deploying, and integrating DevOps projects and on code spaces. And finally, I also have a final session on July 13th that I want to mention today as an introduction to machine learning models. There are more sessions coming from the global team as well on the Reactor Abu Dhabi local page on Meetup. So I encourage you to check that out. I'm going to put all the links in the description. And also, we have more upcoming sessions. So if you check out the calendar, you will see beyond what's happening until July 13th. I just wanted to share those 4 sessions for you to continue the journey and continue learning. And also, feel free to subscribe to 2 newsletters. One is the new Reactor newsletter. This is on our local website, so that's the link. You just you can join and register your interest, whether for the local events in Abu Dhabi or that we're doing, like today's, for example, and the ones that also are coming from different reactors. So this helps you also get these updates straight to your inbox, and we send that every month. So please subscribe to our newsletter, and also subscribe to Microsoft Source, which is also a very interesting newsletter for developer news, events, trainings, and happenings around the region. And also you can continue the journey and explore learning paths, events, and webinars on Microsoft Cloud Society. I think that's it for today. Thank you again, Christopher, our speaker for today's session. And thank you everyone for joining us, and hope to see you joining us in the coming sessions. Thanks again, and we'll see you.
Thank you. Bye-bye.